Hello, everyone. This is Ralph Gwynn. I am head of community development here at Mender IO, and we are here to introduce Hosted Mender this morning or this afternoon, depending where you are. And with me is Drew Mosley. He's our technical solutions architect here at Mender IO. And I'll go ahead and let Drew introduce himself.
Thanks, Ralph. My name is Drew Mosley. As Ralph said, I am a technical architect here at Mender IO, responsible for adapting the Mender system to various use cases. My history is in the embedded space for many years, and I've been focused on embedded Linux exclusively for the last 10 years or so. And we are very happy to present Hosted Mender to you today because we think it solves a real problem in the industry.
Great. Thanks a lot, Drew. And so what I'd like to get started on is why we created Mender. So as many of you know, Mender is an open source project to deploy over-the-air software updates for connected Linux devices. We started this journey about 4 years ago, and we did a number of user tests. What we found were device owners, the majority of them were using homegrown solutions. Now, unfortunately, they typically lacked built-in security, a robust update process. And what we mean by robust is that if an update was interrupted for any reason, whether it's power loss on the device or poor network connectivity, the device would have a problem rolling back to the previous working state. And so, of course, that's a big challenge. Also, what we found were some homegrown solutions did not have fleet management capabilities with the management server. And of course, because they were built in-house, it was not community-backed. And so you did not see a community-backed project that had a lot of contributors. And then almost always, the actual development effort was significantly higher than planned. And so here you can see the development lifecycle for devices and where OTA fits into that. So during our user tests, developers across all industries were rushing to get their IoT product released. And the ability to deploy software updates was considered shockingly very late in the process. And here you can see the typical process of development for embedded, and ideally where OTA should be considered is in the system design phase, second to the left there. But where we typically saw OTA when we interviewed a lot of developers were towards the very end. Someone would bring up, how are we going to update these devices in the field? And that's typically when the rush job happened on creating an update mechanism. And so the vast majority of device makers built their own solution, and because of time to market pressures and thinking about that too late in the life cycle, they were often patchwork solutions. And so we've introduced Hosted Mender. After hundreds of participants in the beta of Hosted Mender, we're really proud to announce its release this month. And so, you know, why we created this project, the developers that we interviewed, they clearly had a strong desire to focus on their core product development and use an off-the-shelf OTA update management solution. So for Mender, our first step was developing an end-to-end solution where both the management server and the client component were freely available to use and licensed under the permissive Apache 2 license. But now with Hosted Mender, we're really proud to let developers just focus even more on their core competency. So we provide as a service the setup and maintenance of the OTA management server so developers don't have to. And just a quick note on who we are. The commercial entity behind the Mender project is Northern Tech. So we're a team with extensive experience ensuring the security of Linux-based devices and systems at scale in some of the largest organizations in the world. And we're a geographically distributed team. We have offices in the San Francisco Bay Area and Oslo, Norway. And here you can see a snapshot of our customers. And why Mender? I'll go ahead and leave this to Drew.
Great, thanks, Ralph. So the purpose of Mender is to deliver over-the-air updates to connected Linux devices. Our prime directive in designing this product was to ensure secure and robust updates. By robust, we mean that there is little, if any, chance of the device being bricked in the field. And that's always a risk when doing over-the-air updates, and it gets very expensive if you have to send technicians on site and that kind of thing to manually update these devices. So our focus was that a update would either ever be completely installed or not installed at all. Only the update system running on the client hardware would ever see a partially installed update. All the other system software would not even know it existed. So we use a fully dual root file system partition layout to ensure proper rollback capability in case there is an issue with either network connectivity or power, or simply a buggy update that gets installed. We allow device groupings in the management server to allow you to control the rollout using a phased approach to avoid sending potentially risky updates to your entire device fleet at once. You can start to get telemetry back and determine if the new device updates are sane before rolling out to the wider group. Additionally, with the full redundant root file system capabilities, that allows the update process to proceed completely in the background and not interrupt the end users of the device. The updates can be installed and streamed while the device is operational. The only time the user will need to get involved is once the update is installed and the system is ready to reboot. In terms of secure updates, we use industry best practices. All communications between the client running on the target and the management server running in the cloud is secured via industry standard TLS. We also provide code signing via cryptographic signatures that can be applied independently of the management server to break that link between your CI system and the management server. A couple other things to think about with Mender. One big advantage is that it's a singular complete solution. We have both the back-end server, which we are providing today via Hosted Mender, as well as the client that runs on your target. Additionally, we can update both the kernel and applications in one single mechanism. That allows you to do a full update of anything that may be potentially vulnerable on your target in a single update. The client runs on the target and does obviously support the managed updates with the server, but there are additional use cases where you can run the client in a standalone mode if, for instance, you have a device that's not connected and you have a magic USB key with updates on it. You can still get the benefits of the robust dual root file system approach by running the Mender client in standalone mode. We have a pretty extensive scripting interface that will allow you to adapt to specific use cases and customize the Mender client for your particular application. Additionally, if the customization provided by our scripting interface is insufficient for your needs, our back-end architecture is all based on microservices. So if something is not available that you need for your particular system, you can get access to the functionality you need through the API, which is all documented publicly on our website. And it's entirely dependent. It is expected to be very low system overhead. The download and installation onto that dual root file system generally is not even noticeable when looking at system logs.
Great, thanks, Drew. And so, moving on to why specifically Hosted Mender, one of the keys here is that we really want folks to focus on getting their product released. And so with Hosted Mender, we have the automatic setup of the OTA management server infrastructure. This also includes the container orchestration and management of the Mender backend. We've heard in the early days before Hosted Mender that folks trying to deploy the management server on premise, they didn't have much experience with setting up and maintaining Kubernetes, which is part of the Mender backend for at least for production. And so with Hosted Mender, we can take care of that for you. Of course, there's also automatic updates of the Mender backend too with Hosted Mender. On number 2 here, on the security side, very clearly with Hosted Mender, you have the latest security patches to emerging threats. So that's taken care of for you. The data is completely confidential. We encrypt it so that your customer information is safe. And we have a full audit trail. So with both the API and database access logs, you have a full view into that. So if there were any problems, you can detect who accessed where. And on number 3 there, Hosted Mender takes care of scale and uptime for you. And so, of course, with container orchestration, it also allows us to auto-scale the infrastructure for you to meet your device fleet growth. And our team, of course, is actively monitoring Hosted Mender. And in fact, we only got out of beta earlier this month. But for the last 90 days, including our beta phase, Hosted Mender has had a 99.94% uptime. So we feel that it's a very robust hosted solution for getting updates out to your devices.
Great. So let's dig in a little bit more on some of the security features that are enabled through Hosted Mender. Obviously, one of the tenets of any secure system is to be able to apply the latest bug fixes and security patches. The Mender Updater itself is intended to allow you as the system designer to apply the latest updates and security patches to your target devices, and Hosted Mender allows us to handle that on your behalf on the server side of things. Outdated software is generally the cause of most issues. Zero-day flaws are found all the time, and the ability to respond quickly to them is vital. And if you are not in the business of handling enterprise cloud-based software, building that team and that expertise takes time and investment that your product may or may not be able to support. As far as specifics on the Hosted Mender, we do have a load balancer that is in front of all the Hosted Mender services. That gives some degree of protection of the internal services. The services themselves are not directly available. Authentication is all handled directly through the load balancer, which additionally handles large amounts of traffic coming into the Hosted Mender server to ensure that you get the response time you need from the server. And within the Hosted Mender infrastructure, all of the internal networking is handled in some virtual networking that's behind and not visible on the greater internet. This avoids leaks of your sensitive information. Security features that are available to you as a user of Hosted Mender, all the API accesses are logged and can be reviewed when there are evidence of nefarious activity going on. All the database information is encrypted internally with proper TLS access to ensure that all your data is kept confidential. The database access logs are backed up, and the actual access to the database logs is tracked so that can be reviewed when needed. So moving on a bit to the scale and uptime features, the Hosted Mender setup is extensively monitored. We have a number of different monitoring systems in place to maintain and keep an eye on things to make sure that the Hosted Mender system is up and running for you. Our goal, obviously, is to fix issues before they become visible to our end users. And if you are hosting this yourself, it can get expensive. It does require automation and systems to detect issues, and it requires engineering staff to respond and fix the issues. So we have implemented all of that, including the service monitoring, testing of updates, automatically rolling out updates, managing the service certificates. It's very easy to let that go past its expiry date without realizing it, and end up causing downtime with that. Additionally, we handle auto-scaling automatically. We use Kubernetes inside the Hosted Mender setup to make sure that the server capacity can grow as the device fleet grows. We handle auto-scaling horizontally across all our microservices so that those are automatically scaled as needed. We do cluster across multiple cloud zones to ensure the most robustness that's possible in case of downtime of an entire data center region. And we do have some rate limiting that will handle any API abuse or malfunctioning devices to make sure that they don't significantly impact the ability of other users to access the system. So a bit more detail, we do have a 3-node replica set of all our databases with redundancy and simultaneous availability built in. This avoids issues, obviously, if there are issues connecting to the database. Having the multiple nodes out there does give us a bit more redundancy. Backups are done every 6 hours so that if data is unintentionally deleted, the amount of data that's lost will be minimized. And all of the artifact storage is handled in the cloud, and it's always available for your device fleet to get access to. And with that, we'd like to move into a demonstration of Hosted Mender. So this is Hosted Mender. You log in at hosted.mender.io. One of the first things you'll notice when you log in is that it looks very similar to the on-premise Mender that we've had out for some time now. We start at the dashboard here, which is kind of your at-a-glance view of things. You see things like the number of devices waiting to be authorized, number of devices used, number of devices available, status of in-progress deployments, previous deployments, and that kind of thing. From here, we'll move into the Devices tab. Also, you can find help, account organization information at any of the screens. From the Devices tab, this is our standard device view. We'll start off with the Rejected Devices tab because I know that in my case, I have a few devices that I've explicitly rejected. I'll go ahead and select them all and readmit them to my fleet. And those will be then starting to connect to the Mender server and be readmitted, retransmit inventory information, and just generally go through the standard workflow. Similarly, for the pending tab, I had a number of devices in this case pending authorization for the first time. I'll go ahead and authorize those all into my fleet as well. At this point, all the devices that were just admitted have started transmitting their inventory information. You see them starting to come through here in the main device tabs. So now, if we drill down into a single device, you see the standard information you would expect. In the out-of-the-box configuration, we have the general type fields such as MAC addresses, device types, CPU architectures, things like that. That information is all available here. We also have a grouping mechanism. In this case, let's create a group for early adopters so that we can roll out, for instance, a beta release to just a few devices to avoid putting our entire fleet at risk. So now we're presented with the entire list of devices, and we select the individual devices we want to have in this group. I'll put my BeagleBone and a Calibri board in the group. Now, in the group here, you see just the devices that are part of that group, and you see the current software image on them is both 0.0. One feature that is unique to Hosted Mender is the device filtering. This allows you to filter this device view based on any of the inventory fields you see here. For instance, if I want to see which of the devices I have in my fleet that are emulated devices, I add a filter for device type of vexpress-kimu, and then I see only those particular devices. From here, we'll move over to the Artifacts tab. This is very similar to what you've seen before in the on-premise installation. You can drill down into any of the artifacts you have available for installation and see things like the build date, the build size, the general kinds of information that would be useful for understanding these artifacts. Now we'll go ahead and create a deployment. We will select the artifact that we have, which is the release 1.0. It's compatible with a number of devices. And then we'll go ahead and select the early adopters group that we recently created. And here you see that 2 of the devices will be updated. That means that I have a compatible artifact for both that Calibri board and the BeagleBone. So now our update is in progress. On the next check-in from either of those devices, they will be informed that there is an update available for them, and they will start updating. So we can view the progress here. You see that both of the devices have started the download and are in the process of downloading and installing. Now, if there is an issue with the install, the logic in the bootloader will detect that issue and automatically roll the system back to the 0.0 image. In my case, I'm going to unplug my BeagleBone board to simulate a failure, and within a few seconds, we will actually see that the BeagleBone system has been detected as failed and will be reported as such. In this case, the Calibri board is continuing to download. And now we see that the Calibri board is rebooting. And now we see that BeagleBone has been reported as a failure. We can view the log to help troubleshoot what the cause of the failure was. In this case, there won't be a whole lot of relevant information since I simply power cycled the board in the middle of an update. But that information is available for review in the case that there are issues with any of your deployments. And now we see that the Calibri board has finished its update successfully. And if we move back over to the Devices tab, we'll see that the Calibri board is now successfully updated to the 1.0 release, as expected. And that's Hosted Mender. So moving on, we want to go into depth a little bit here about the scripting interface that was mentioned earlier. This is the mechanism that can be used on your client devices to customize Mender for your particular use case. This is the standard state machine that the Mender client is implementing internally. So let's talk just a little bit about a few possible use cases and where this might be useful. One common use case is for data migration. If your application has updated to a new database format, or there's some kind of manipulation of the data you need to do to be able to move to a newer release of your software, you can implement a script on the exit from the artifact install state, which handles the migration And if all of that is successful, if everything looks good, you run some tests in your data migration script, then it simply transitions into the artifact reboot state, and the Mender client continues with the successful update. If there's an error in the data migration, your data migration script will then make sure that any changes it has made are undone, and it will fail out of that script, and it will transition into a rollback state. Another very common use case is to get end user confirmation before rebooting the device or before installing in general. So you could actually set up a sync exit script to prompt the user, much like we're all familiar with on our smartphones. There's an update available. Do you want to install it? The user can decide if now is a good time or not, knowing that that's going to take up some bandwidth. It's going to take up some CPU cycles, and eventually it's going to cause a reboot. So this is a very common use case. The primary use case is for custom sanity checks. So this allows you, as the system designer, to plug in additional checks on a new installation to make sure everything looks good. This can be anything that's relevant for your particular application, whether it's checking device driver functionality, checking the database sanity, whatever might be useful for your particular use case. The Mender client itself will check network connectivity and ensure that communication with the hosted Mender server is sane, but your particular use case is likely going to have custom checks that need to be run, and any of those checks can fail and will trigger a rollback of the system. And another possibility is to help with power. You might want to enable networking only periodically. So you would set up a sync enter script or an idle exit script to enable networking before trying to communicate with the server. That allows you to keep the networking devices disabled for longer periods of time for power savings and the like. Additionally, if your device has a low-speed networking connection, which is maybe lower power, and a high-speed networking connection that you want to use for actually downloading new artifacts to install, you might actually have two separate states where you enable networking over the low-power connection to check the server, and then enable your high-powered connection, which would typically be Wi-Fi or a wired Ethernet, before to actually download any particular artifacts. Similarly, on artifact reboot, if networking is not always enabled, you might need to enable it on reboot, just so that the initial connection between the Mender client and server is handled properly on reboot of a new update. And at any of these states, if there is a reason not to enable the networking, if you detect for some reason that you're in an area with spotty coverage, or you check the battery level and your system is concerned that the battery level is too low to support downloading an update, you could always defer the updates at this point until a more appropriate time. And with that, I think we want to thank you all for attending. We have time for questions. Ralph, I'll hand it back over to you.
Great. Thanks a lot, Drew. So we do have a question about pricing for Hosted Mender for 1,000 devices. And what we've done is we have a pricing calculator on our website. So if you just go to mender.io/pricing, you can actually calculate the pricing for yourself. And so it is a usage-based model, so it is dependent on the size of the update artifact, the frequency, of course, of the updates, and the size of your fleet. So you can do that directly on our website. And another question is, how many devices can I connect to Hosted Mender? I saw a limit of 500 in the demo. Drew, did you want to take that?
Sure. So by default, 500 is the default unless you specify otherwise. You can always increase that number to whatever you may need. Obviously, that will play into the pricing calculator that Ralph just mentioned. We want to make sure that the sufficient resources are available as new users come online. So we definitely we don't normally set the number much higher than that.
Great, thanks, Drew. And do you offer support on Hosted Mender? So if you have any questions or feedback while using Hosted Mender, you can always contact us. The email is support@hosted.mender.io. And one of our customer service staff will, of course, get back to you as soon as possible. And I think that's all the questions that we have. So we'd like to take this time, of course, to thank everyone for joining us on this. Obviously, this will also be recorded and be on Google Hangouts on there, so we'll make sure to make that publicly available once we have the link. And if you have any questions to follow up with, you can always email us at contact@mender.io. But otherwise, thank you very much for joining us, and we look forward to speaking to you. Bye, everyone.